This is where I make Fluorospec. Let's go inside. You might think that the running is a gimmick, which it kind of is, but I am in a rush to end lead poisoning. That's why, in addition to manufacturing Fluorospec, I innovate solutions. This is going to detect lead-based paint dust and quantify it. This machine is awesome. It fills up 24 bottles of Fluorospec at once. And this is that ring I was talking about. 5 times more sprays with this. Looks good. Methylammonium bromide detects lead-based paint and other forms of lead by using fluorescence induced by the formation of a crystal called methylammonium lead bromide. It looks like this. Most people are actually poisoned by lead dust. Let's observe some. This is the before shot. So the idea of this box is that it blocks all the excess light. You spray the Fluorospec into the area, and you can see those particles of lead-based paint dust are much more obvious now. Another way to detect lead is using X-ray fluorescence spectrometry. All you have to do, shoot the X-rays into the paint. Right now it's being represented in milligrams per square centimeter, but if we change the mode, we can represent that as parts per million as well. That's a lot of lead. This thing costs $50,000, but let's see what $50 can do when we use fluorescence spectroscopy instead of X-ray fluorescence spectrometry. With fluorescence spectroscopy, we're just looking for a color change which indicates the presence or absence of lead, unlike the spectrometer, which tells us exactly how much with a number. Here's another example of a spectrometer. This is an atomic absorption spectrometer with a graphite furnace. It can see down to 1 part per billion lead in water, for example. But the thing is, all the samples have to be digested. That's a pretty big job. And it's not as easy as I thought. This entire lead thing has been way harder and way more involved. And it's not to mention expensive. Would you believe that this plastic container costs $2,000? I'm on a mission to lower the cost of lead detection. I don't have a PhD, but I do have an appetite for science and innovation. So if you have any questions, feel free to contact me, eric@detectlead.com, or at ericeverythingled on Instagram. I'll see you later. Making lead test kits isn't rocket science. It just involves packaging a liquid that's relatively easy to make. Let me show you the barrel I mix it in. Now, the chemical test is flammable, so this is an explosion-proof mixer. But what I do is I screw this into a barrel of isopropyl alcohol, add about 2.5 kilograms of methylammonium bromide with mandelic acid, and that's how you get the testing fluid. It's not that complicated, but it is really effective at finding lead. Here's an example of a product I found that had lead. The outside has lead, the inside does not. A CSPC leach test fails to identify the lead on the exterior. To make the situation even more complicated, it was marketed for use by children, but tested as a cup. Figure that one out. That company sold for $205 million. I was doing some lead-based paint dust research over here the other day. And this is the first prototype of that thing. The second one is much better. These are the ultraviolet lights. Anyway, let me know if you want any other information, and I think that basically covers it. Thanks so much for talking today. All right, bye for now.